So hey, we should get started. I mean, I'd love to wait for people to finish their coffee, but you know, we're sticking to a tight schedule here, I think. So, oh yeah, that's helpful. Hey everyone. So first, thank you for being here. Thank you for being at our session, but the whole thing, because that means you care about open source security, and that is half the battle. Right, yeah. So I'm Katherine Druckman. I am an open source evangelist at Intel. And this is my colleague, Ryan Ware, who is awesome, and I'll let him introduce himself.
Yeah, I'm Ryan Ware. I'm Director of Open Source Security, and I have lived my entire career at the intersection of open source software and security in lots of different ways. So
it's a fun intersection. So Ryan, why are we here again? Can you tell us, why is open source security so challenging, and what is unique to open source?
So there's lots of different reasons why open source security is an interesting place to be, shall we say. First of all, there's a huge spectrum of open source software out there. Everything from things like the Linux kernel and the Chromium browser, which have dozens, if not hundreds of maintainers, all the way down to open source projects that have one maintainer and not everybody knows about them, and lots of different motivations. Like here, I'm doing this project for work, but this project over here I do as a hobby. And hey, we may want to do some things here, and we may not want to do things here. So it's an interesting space to try to figure out. Here, these are global things that all open source projects need to do.
So we have some stats actually to make that even clearer, to really drive it home. So, open source truly is everywhere. So getting security right is obviously very important. According to a 2024 Synopsys report, though, it showed that 96% of their rather nice-sized sample of code bases contained open source software. And of those, 77% of the code within those code bases was open source. And then according to the Linux Foundation, in 2022, 70 to 90% of any given software is made up of open source components. So, yay. Oh, I messed up our fireworks there. Hold on, you gotta see this. This is pretty cool. So yay, we won.
Yay, we won.
We won. But Ryan, what does it mean, though, that we won? What is the significance of that? I mean, if you've been around open source for a while, we've had these conversations on legitimacy, and we worked hard to get here. So what does it mean?
So what it means is there's open source software in pretty much everything. I mean, when I look at, I work for Intel, so that's my reference for a lot of these things. But when I look at Intel software products, there's open source in everything we ship, and it is it can be difficult trying to figure out. Okay, here, say I have this one project, it ships 2-3 open source libraries. It's pretty straightforward what people need to do there. You look at other projects that have 10,000 open source projects in them. How do they keep things up to date? How do they do things securely? And there's lots of different things you look at to help make sure that you're doing the right thing, and we'll talk about some of those. But yeah. It's a challenge.
Yeah. Okay. Let's start digging into that challenge. So Ryan, you want to talk about? Let's talk about packages and how many of them there are.
I mean, the number of packages is huge. Look at Node, NPM. First of all, there's lots of new packages being made every day and added every day. If you look at something like Node.js, it has 3.6 million packages in it. There's like 1,000 brand new open source projects going into Node every day. What are all of those things? I don't know, and you probably don't necessarily know either, because these things get added into your project at like 3rd, 4th, 5th level dependencies you never even see, and the number of projects is just huge. And trying to figure out how you handle all of these is difficult.
Yeah, and who among us has not worked on a piece of software and found something flagged by, I don't know, static analysis or your package manager, and you're like, what is this dependency? How did that get in there? Anyway, we've all done it. So yeah, massive number of packages. Now the other thing to think about is CVEs, right? So in the good old days, we all know what CVEs are here, I assume, so common vulnerabilities and exposures. But in the good old days, they were far less frequent. But as you can see, they are massively on the rise. So Ryan, like this doesn't mean that software is becoming more vulnerable. But what are your thoughts on what it does mean?
So there's definitely a few different things that it means. So first of all, I remember back in 2017, and I did a talk on CVEs, and I talked about how horrible it was. We were doing 35 CVEs a day on average. Sweet summer child that I was. You know, we're at almost 29,000 last year. We're going to far surpass it this year. Maybe with just the Linux kernel alone. But it doesn't necessarily mean that software is less secure. There's a few different things it means. One, we have a lot more software than we used to. Especially if you start looking at the lines of code. I mean, 22 million lines of code last I looked for Linux kernel. I mean, that's a lot. And not only that, but we have lots more security researchers out there trying to find vulnerabilities, whether or not some of them are reporting quality issues or not is another question. But we have lots more people reporting vulnerabilities, which is good. We have more eyes on the code. At the same time, we have to remember open source won, and guess what? The whole reason we know about the NX problem is because it was open source.
Absolutely. Yeah, and software is made by humans, right? None of us are perfect, but...
I am.
So let's talk about dependencies.
So dependencies, I mean...
The graphic. This graphic is not that bad, actually. It was just kind of pretty.
This graphic is not that bad. We're going to show you one that is. This is from a Drupal module.
I have to point out, I picked this because it was a nice tree visualization, but this is a deprecated Drupal module. Yet another example of software you should not use as a dependency in your own project. So, but it looks nice, you know.
Yes, any piece of software today has tons of dependencies. This is actually pretty reasonable.
Shall we go there? Let's go there.
Let's go there. This is a real piece of software. This is a application, node application called Gatsby. And you look at this, and it's an eye chart. You can't even see what these little things are. And if we just expand up on just part of it, these are all of the dependencies, all of the open source projects that this particular project uses. And, some of these are 8, 9, 10, 11, 12 levels down. Who knows what's going on with these? And actually, this graphic is fairly old. I generated it about 3 years ago. Gatsby is much worse even now. So, how are you keeping all of this straight? How do you know what's going on with all of these projects? And there's different things you can look at. It takes work, but you also have to make sure that when you are creating your own open source software and adding dependencies, you aren't adding just direct dependencies. You're adding secondary, tertiary, multiple levels down. It's turtles all the way down, folks.
Yep. Okay. So okay, let's talk about how we're going to solve this problem, right? Right, what do we mean exactly when we say consuming open source software securely?
So when we talk about consuming open source software and doing it securely, it is the idea of here we are adding open source libraries and projects to our own project. And when we do that, we want to make sure that people understand here, this is how you identify whether or not the project you're looking at is something that you actually want to add to your own project and hitch to your own star of fame.
And I would just add, taking responsibility when you include something. We'll talk about that a little bit more if we, if we have time. But yeah, so just really quickly, let's talk about some basic things that you don't necessarily think about when you think in terms of security, but you really need to.
So there's these 5 things that we have here, and we're going to talk in more depth on each of them. But you look at these, and some of them seem straightforward, some of them don't. And we're talking about reviewing basic health. Is the project active? Are there other things about the project that are relevant? Is there governance? Is there governance defined? You might be thinking, oh, we're talking about security. Why are you talking about governance? Well, we'll get to that. Review, maintenance, and releases. Is there a cadence? Explore the community. Are people engaged? And how does bug reporting work? Yeah. These are all critical things to be looking at when it comes to, choosing any new open source that you're planning on using.
Yeah, so let's dig in. Basically, a well cared for project is more likely to be a secure project. So
what's the first thing you would look at when evaluating an open source project to use or include as a dependency? What does anybody have a suggestion, real quick? Right back there. Security, that's good.
Yeah. GitHub. Okay, I like that. I like that answer. GitHub stars.
GitHub stars.
That's sure. I mean, that's part of it. So how about this one? Does the project even have a maintainer anymore? That's a good one, because that happens. Maintainers get a little overwhelmed and disappear sometimes. When was the last commit? Just basic stuff. If it was 10 years ago, that is a flag. That is a really, really dark red flag.
Don't use it.
Look at the issue queue, just some basic stuff. You want to see how active it is, how quickly people are responding to issues, are pull requests getting closed, all of that stuff. When was the last post? If it was, again, 10 years ago, okay. And Ryan, you want to talk a little bit about governance in more detail?
Yeah, I want to talk about governance. And, you might think, what, are we in an OSPO talk? Why are we talking about governance? And there's a reason why OSPOs talk about governance. Governance is, trying to help make sure that projects are well cared for. And a project can't be secure unless it's well cared for. And so we talk about things like, is there clearly defined governance? Is there a clearly stated license? If it doesn't clearly state the license, don't use it. Is there more than one maintainer? If there's just one maintainer, you have to remember, God forbid they get hit by a bus, but if they do, you're stuck. Maintainers from more than one organization or more than one company. That way you aren't beholden to just a single person. And then, how are decisions made for the project? Can you actually influence the direction of the project if that's something that you want to go do? And so, these are all things that you want to make sure you're looking at and understand before you choose something.
So I want to talk a little bit about maintenance and release management, right? You want to look at the way that releases are handled. What's the cadence like? What is the governance around the release cycle? Has there been substantial release activity in the last year? And look at the cadence. Is it documented and regularly occurring? Do they have a new point release every 6 months? Are they regularly releasing patches? All of that stuff, a good sign of project health. And quickly addressing security issues with new patch releases is a good sign of health and reliability. The other thing that people don't necessarily think about is, does the project communicate with its users regularly? Does it have a blog? That's a great sign that the maintainers are engaged with the users. Here's another one that kind of seems obvious, but is a good reminder. But is the latest release in alpha or beta stage? If so, we've all included beta stuff in our software and alpha stuff.
Don't lie to yourself.
Right? It wasn't just me. But it's one of those things that you need to look at when you're thinking of all of these things kind of as a holistic picture. You have to build the picture that's right for you. You want to talk a little bit about community engagement?
Sure. one of the things that you want to have when you're choosing an open source project to use is, are they active? And one of those things is, do they have a contributor guide? Or, do they clearly define the kind of code that they accept through pull requests? Or do they just take anything? I mean, if I have a security project, I don't want to just take anything. I want to make sure that the project I'm utilizing has clearly defined goals with the code that they're bringing in. Is it extensively used?
Back to the stars.
Yeah, exactly. I mean, are there lots of projects using this, or are you going to be the first guinea pig? How many of you want to be the first guinea pig? And not only that, I mean, like, especially depending upon the kind of project that you have, is this, for example, is this a crypto project that you're going to be a guinea pig for? How happy would you be? Is the community working towards security best practices? I mean, do they have a security best practice CII badge? If so, what's the level of that? Are they doing automated testing with CI/CD? Do they have up-to-date dependencies, or their own dependencies out of date and have known security problems?
The last thing we wanted to quickly talk about is just secure bug reporting. Even larger, even medium-sized projects will probably have a clearly defined process. It may not be as extensive. This example is Kubernetes, but you can find examples in WordPress and Mastodon and GIMP. Any open source software that has a solid number of users is going to have something. But even just a tiny, short piece of documentation is a good sign. What is the risk, Ryan, if you don't see this?
Well, if you don't see this, one, somebody might not report a security issue that they find because they don't think there's a good way of doing it. Two, you also might get somebody submitting a security problem out in the open where anybody can look at it, and they suddenly zero-day their own project. You want to make sure that there is a process for securely submitting security vulnerabilities, as well as making sure that that's done in a way that you can do coordinated vulnerability disclosure across the board.
So we did also want to quickly point out that there are a lot of folks out there in the community, a lot of them are here, working toward solutions, right, and tools for these to make these problems easy to address, make the secure way the easy way, right? So we want to quickly plug. Here's a project maintained by the lovely Terry Oda at Intel, and the occasional Google Code student and other contributors. But it's a CVE bin tool. You can speak about it, frankly, better than I can.
CVE bin tool, it looks at binaries and does software composition analysis and lets you know what's inside of it. Yeah. And it's a great open source project. If you haven't looked at it, go look at it. Yeah,
check it out. Good stuff. We'll have links to this, by the way, at the end in one of those nefarious QR codes. The other quick thing we want to plug is the OpenSSF, hey, here we are, best practices badge. So, this is, again, a quick, easy thing. Obviously, not all projects have adopted this yet, but I think it's growing, and we hope it continues to grow. But it's a quick thing, right? You can see the status. Is it passing, gold or silver? There are varying levels of compliance. And then you can drill down in the web interface. Oops, wrong direction. Sorry about that. In the web interface, if you look at all of the regularly scanned projects or checked out projects, let's say, you can drill down into the various criteria. So you can see what's passing, what's not, what they're still working on. And it gives you, again, a picture. This is not to say you have to only use projects that have a gold badge or even a passing badge, but you want more information in order to make those decisions. And then the last thing, here, I'll let you talk to this one.
I think people may have heard me talk about Scorecard before, possibly.
Hope so.
I love Scorecard. It's great. It's helping Intel find insecure software in our own repos. You should use it whenever you're looking at adding a new open source project to your own open source project. Enough said.
Yeah. What does it protect you from?
Lots of stuff that we don't have time for.
That's fair. Okay. So this is the output of Scorecard. Check it out, use it, incorporate it into your workflow. We use it at Intel. Ask us after. We want to leave you with this final thought. Might be a little controversial, but developers don't owe you anything. If you install it, you now own it. And I think that's if you take one thing away, you need to give these things care and feeding. So really quickly, we have a link. I promise it's safe, really. Everything we talked about is linked here, some links to tools, a PDF. So check that out.
Please use my QR code.
Yeah. Give everybody a chance to snap it. And if you don't, again, find us after, or find us at any of these places. And that's all we got. Thank you so much.
Thank you, everyone. Really appreciate it.